Next, we have to tell the order of minus I effect in these three cases. So we have to tell the order of minus I effect. Now, you can see that the three cases are SP, SP2 and SP3. So what we need to do first is I will write the percentage of S character in each one of the cases. So percentage S character, if I define for each of these cases, let us see. For SP, we have got half of them as S, and out of 100%, so we get a 50% S character. For SP2, I have 1 upon 3 and 100% out of 100%, and that gives me 33.3%. Out of 4 atoms, I have 1 as of S character, and I've got 100%, and so I get a 25%. So you can see that we have got 50%, 33.3%, and 25%. These are the S characters of all of these respectively. Now, there is this one condition which you have to remember is as the percentage S character increases, so any increase in the percentage S character is directly related to an increase in electronegativity. So electronegativity increases. So percentage S character increases, leading to the increase in electronegativity. And now we remember the first case which we studied was that when electronegativity increases, this leads to an increase in the minus I effect or in the electron withdrawing effect. Okay, so what I've just said is that if percentage S character is increasing, the electronegativity is also increasing and minus I effect is increasing. So we can mark easily that the increasing S character is in this series. SP is greater than SP2 is greater than SP3, and therefore the minus I effect will be in the same series. So SP minus I effect will be greater than SP2 will be greater than SP3. So all of them are actually related with the percentage S character, and this is explained by this. Now, the next one is a clear case of what we have just done, and we'll do it using what we have just learned about how increasing S character leads to an increase in electronegativity. Now, how and why is that? See, in these cases, we can mark and see that this that is this phenyl group is sp2. We have sp2 carbons here. Here again we have sp2 carbons, and in this case we have sp carbons. So previously we have done that sp carbon has greater electronegativity than sp2 carbon. So one order is already clear to us that in minus I effect that we'll see case 3, that is CH triple bond CH will be greater than the phenyl ring as well as the second one. So we are clear that the third one will be greater than the first and the second. Now we have to decide which is greater from the first and the second. So I'll just mark the first. So this is the first one for us. This is the second one for us, and this is the third one for us. So we have to see out of the 2 and 3, we have just decided that the third one has greater electronegativity, therefore it has greater minus I effect. Out of the first and second, we have yet to be decided that which one will have a greater minus I effect. Now, there is this one condition that we have to remember again, which is as the number of carbon increases, this leads to the deduction that minus I effect increases. But there is a condition attached to this, which is that this occurs in same hybridization. Now, the hybridization here, which we are referring to as same, is the sp2 hybridization. This is also sp2 and this is also sp2. But we have to differentiate which has the higher minus I effect. So what we do is that we see the number of carbon which has the higher number. So in this one, that is the first one, we can count that there are 1, 2, 3, 4, 5, and 6 carbon. And in our second case, there are 1 and only 2 carbons. So this has 6 carbons and this has 2 carbons, making it very clear to us which will have a higher minus I effect. So out of 2 and 1, minus I effect of first is greater than second. Okay, so let us write the final order, or we'll just write the conclusion that we have just derived, that the order of minus I effect, rate of minus I effect will be in the order that the third one is greater than the first one and that is greater than the second one. So this concludes this example that we have just shown to you.